Hi everyone, this is Math 082 video 4.1, Greatest Common Factor. This is my second video in 4.1. So the first question I'm going to answer is, what is factoring? Okay, the hidden answer, most people don't realize, is that factoring is really just dividing. So we have a factored form, and we have what's called an expanded form. So a factored form would look like this: A times the quantity of B plus C. So back in chapter 3, we practiced distributing and multiplying. So we use the process of multiplication to get from A times the quantity B plus C to the expanded form, which is AB plus AC. In this chapter, we start here with the expanded form. We start with AB plus AC, and we ask ourselves, what do they have in common? They both have an A in common, so we use factoring, which is really division, to factor out what they have in common and to arrive at the factored form, which of course would look something like A times the quantity B plus C. Okay, so just to reiterate, this is the process that we did in chapter 3. This is what we'll be doing in chapter 4. So let's start with a process problem here. So we have 6x cubed plus 12x squared plus 4x. So when we're finished, what we want is we want to have the GCF out here, and then whatever is left over, we want on the inside of the parentheses. So in the previous video, we practiced finding our GCF. So remember, one method of finding your GCF, and you certainly don't need to do this every time. If you can do the mental math, that's totally fine. But one way to figure out what the GCF is for the numbers is to draw your prime factorization tree. So if that's something that works well for you, feel free to continue doing that. So remember, for the GCF, we go through and we circle all the numbers that we have in common. Okay, so far our GCF looks like it is 2. Okay, and then remember, for the variables, we have an x cubed, an x squared, and an x. And remember, we choose the lowest exponent of that variable. In this case, that's going to be x. So we know that our GCF is 2x. What we don't know is what's left over after we factor out, or again, really divide everything by 2x. So let's rewrite that problem down here and see if we can figure this out. So to find out what's left over after we factor out or divide by the GCF, we can divide every term by 2x. So let's see what happens when that happens, when we do that. So 6 divided by 2 is 3. X cubed divided by x is x squared. This is 6x, and this is 2. So this is our final answer. So again, this is our GCF, and what's inside of the parentheses is what is left over. The nice thing about these kinds of problems is that you can always check yourself. By going backwards and distributing the 2x to each term, you can verify that you did your multiplication properly. So when I go back and distribute, I end up with 6x cubed plus 12x squared plus 4x, which is what we started with. Let's do another problem. This time we have 21x cubed plus 14x squared plus 7x. Okay, so this time I want to write it out a little bit differently. So 21, as you know, is 7 times 3. This is 7 times 2. So this time I'm going to write it out like this. I have 7 times 3 times x times x times x minus 7 times 2 times x plus 7 times x. So let's go through and circle what we have in common. So every term looks like it has a 7, and looks like every term has an x. So that means that our GCF is 7x. So remember I said what goes inside the parentheses is what's left over. So what's left over after we factor out the GCF in the first term is 3x squared. In the second term, we have a 2x left over. But what about right here? There's nothing left over. But if I stop there, you will notice that if I then go back and try to redistribute this, that I will only get 2 terms, 21x cubed minus 14x squared, right? Whereas I needed to have 3. So how do I somehow change this so that I have a placeholder, so that when I multiply it again, I have 3 terms and not just 2 anymore? Well, remember our ninja number, right? 1 is our ninja number. We can always multiply anything we want to by 1. Okay, one of the most common mistakes I see students make is to leave out this 1. Okay, again, this 1 is acting as a placeholder so that when I do go back and check my work and redistribute this, I get 21x cubed minus 14x squared plus 7x. If this 1 wasn't there, then I would have lost this 7x term. So it seems trivial, but you really need to make sure you remember that that 1 is there. Let's try the same problem the other way. The other way I taught you in the last problem was to divide all of our terms by the GCF. And then that's how we figure out our leftovers in this problem. Okay, so let's see if it still works. 21 divided by 7 is 3. X cubed divided by x is x squared. 14 over 7 is 2. X squared over x is x. And just as I mentioned, 7x divided by 7x is not 0, but 1. So let's compare our answers. Do our answers match up? Are they the same? Okay, it looks to me like they're exactly the same. So when you do these problems, if you want, you can write things out in factored form. That's one solution, is to write it out. Or the other way is to find your GCF and divide by your GCF. Okay? So either way should help you arrive at the same answer. All right, let's do a few more problems here. So in this problem, we have negative 12x to the 5th plus 6x to the 4th minus 8x to the 7th. Okay, so for our numbers, we have 2 times 6. I'm going to ignore the negative for now. We have 2 times 3, and we have 2 times 4. So So numerically, it looks like our GCF is 2. And remember, algebraically, we're going to take the lowest term of x, which in this case is x to the 4th. So let's bring down our expression here. We have negative 12x to the 5th plus 6x to the 4th minus 8x to the 7th power. And remember what our goal is to get 2x to the 4th factored out, right? And whatever is inside the parentheses is our leftovers. And our leftovers come from dividing every term by the GCF and seeing exactly what I said, what is left over. So let's see. Negative 12 over 2 is negative 6. X to the 5th over x to the 4th is x. Then we have plus 3 here. And then we have minus 4x to the 3rd. So that's our answer. Here's a question. Instead of doing that, could I have chosen to factor out negative 2x to the 4th instead? It turns out I could have. Then I would get positive 6x minus 3 plus 4x cubed. So both of these answers are equally valid. All right, let's do one more problem. We have 8ab minus 17c plus 49. So if you want, you can take a second and factor out your numbers. 17 is prime, 49 is 7 times 7. So very quickly we see that none of the numbers have any factors in common. So then we turn our attention to the variables. We have an a, we have a b, and we have a c. So if this happens and there's nothing that you can factor out from all three terms, we just say that the expression is prime. Okay, and that's it. This is your answer.